So now we're going to look at a couple of Excel's lookup functions. There's two of them that we're going to look at, the H lookup and the V lookup, which stands for horizontal and vertical. And they are very useful for dealing with lists of information. The fact is that in the business world, in the workplace, most of the information you're going to get is going to come in the form of some sort of list, like customers or orders, invoices, employees, that sort of stuff. So one of the things we haven't done much thus far is deal with lists, and now we're going to look at how to process lists. Typically lists are related to one another. So in today's example, we're going to take a list of widget orders and look up their prices and weights and that kind of information to build up a complete order information. So let's take a look at the worksheet that we're going to be dealing with here. We have a set of widget orders here, and for each one the facts we're given to begin with are the order number, which we actually don't care much about, the model of the widget, and the type of delivery service that the customer wanted. So the customer bought an A470 widget and wants it shipped overnight, and this guy bought a 600F widget and wants it shipped at ground. We're going to use lookups to complete the remainder of the table here. Now down here we have a widget table that for each model of widget gives us its price and weight. So for example, the A740, if I scroll down here, you know what, I'm going to come up here and collapse the ribbon so we can get more of the worksheet on board. So take a look at, here's the A470, and if we scroll down the list, it's here. It costs $233.24 and weighs 72 pounds. So we're going to get the information out of this list for its price and its weight, and we're going to put them in these columns. And then over here we have a weight charge that is the amount that is charged based on the weight of the item, and it's a little bit kind of different table. It doesn't have every single possible weight in it, whereas this table has every single possible model of widgets. This has ranges of weight. So from 0 to 10 pounds we charge $5.50, 10 to 25 we charge $7.50, and so on. These two tables here, these two lookup tables, are vertically oriented. This table's different. It's oriented horizontally. So here we have for overnight delivery, we charge $25, for 2 days $14, and for ground delivery we charge $0. And in currency formatting in Excel, a 0 is displayed as a $ with just a dash in the field. So the first thing I want to do is create names over everything so that I can use them in the formulas I'm going to write. So I'm going to come up here and create names over the table so I get all these column named. So I'll go create from selection, and I want to do the top row, and I'll click on that. Now I want to create names over these tables down here. And I am not going to include the headers in the names, and I do want the whole range. So I'm going to select this range like that, and I'm going to call it widget underscore table, and press enter. So now I've given this the whole name, and notice I excluded the headers out of here. Just I want the data and the model price and weight columns. Over here I'm going to do the same thing, leaving the header out, and I'm going to name this one weight charge table. And then finally over here I'm going to do the same thing, but this is a little trickier. The headers, because this is a horizontal table, the headers are these two cells here. Overnight, 2 day, and ground are actually data, whereas the word service and the word charge are headers. So I'm going to exclude the header cells, these two here, and name this one delivery speed table, just after the headers that are up here. So they have the same names as the titles on these tables. Okay, so now we're set up and ready to go. For price, I'm going to use the V Lookup function. So I type equals V Lookup, and the first thing it wants is the lookup value. That will be the name of the model, because we're going to use the name of the model, like A470, to search this table. So I'll put in widget model, comma. Now, table array. That's the lookup table down here that I named widget table. So now we know that we're going to use the value from this table to look it up in this table. What we want to get back is the price. So we need a column index number, which is the index. It's the number of columns we step over in order to get what we want. The value we're searching for is always in the leftmost column. So that's column number 1. So the system will search this column for the value, and for example, when it finds 600F, it needs to know how many columns to the right to step in order to get the value we want. We want to get the price. That's column 2. So this is column 1, this is column 2. So we put a 2 here to say we want to step over to the second column and retrieve the value. Then finally, the range lookup value. And it has 2 possible values, true or false. True stands for an approximate match, and false stands for an exact match. In this case, we want to do an exact match. So let me fill that in, and then I'll explain what happened. Okay, so we wound up with the $233.24, and here's the way it worked. The lookup plucked the value A470 and then started searching the widget table in its first column for the value A470, and it went all the way down to here and found it. It then stepped over to the second column, 1, 2, and retrieved the value 233 and put it here. Now let's propagate it down the column, and you'll see it'll pick up the price excuse me, on each one of the values and plug it into the table. Let's check. The D30 says it's $760.18, and sure enough, there it is. Okay. Now, exact match means that when it searches the table for A470, it expects to find that exact value. And if it doesn't, let's just come down here and misspell A470. I'll put an X at the end of the name. If it doesn't, you get an error. Okay? So the $NA means it searched the entire table and could not find the value exactly the way we have it here. So it requires an exact match. The exact matches are important in a table like this because we expect this table to list every single possible widget model. And they need to be in there. The table is exhaustive. It's complete. It has every widget model in it. And we expect an exact match. And so we wind up using the false argument out here, which means exact match. So, whoops, I put it in there twice. Let's get rid of that. So that's the basic lookup of a vertical table that requires an exact match. So we've got the price. Now let's go get the weight. It's very much the same function. We're going to use a VLOOKUP here. And we are using the widget model to do the lookup. We are looking up in the widget table down there. The only difference is now instead of plucking the value from the second column, we want to pluck it from the third. So that is the model number is column 1. The price is column 2. We want to pluck the weight from column 3. 3, and I want an exact match, so that's a false. So we get out of 72, and let's just verify it. A470 is 72 pounds. Propagate it down the column. And we have the 2 columns filled out with price and weight. Now, just to recap what's going on. It's a vertical lookup because the orientation of this table is vertically. That is, the model number that we're searching is oriented in a column, not in a row like it is over here in the delivery speed table. We are looking up the model number in the widget table. We're stepping over to the second or third column depending upon whether we want price or weight. And we use false here because we expect to find an exact match in the table of the model number, because the widget table model list is exhaustive. It's every single model that's possible in the system. Notice that the column isn't sorted. The model number isn't sorted, and it doesn't need to be, because the system will just scan down the table until it either finds the value it's searching for or gets to the end of the table not having found it, and that causes an error. Next, we'll go on and look at the approximate match.